Okay, this video we're talking about electrolyte solutions, and the first thing we have to talk about is what is dissociation.
You guys finished to do that?
Okay.
You automatic?
Dissociation is when we have two ions and they separate from each other, and this is going to happen in, so this is a separation of ions in solution. Okay, so in this case, if we have a solution, let's say we have water, we can also call this ionization, and this is because it breaks up into, typically your ionic compounds are going to break up into cations and anions. Okay, and so dissociation or ionization is only going to happen with ionic compounds. Okay, and so here's what happens. If I put sodium chloride in water, so I have NaCl, okay, what this does is you have water and it comes in here and it's going to cause these to dissociate. Okay, and so what I get is Na with the plus charge, and I get Cl over here with the minus charge, and the waters come around and they surround this. Okay, so we get the negative end of water. Remember, this is a partial negative, and you have your partial positive end over here. Whoops, you can't see that. And we're going to get another water to come in here. Okay, and we'll probably have another water. And these ends all kind of line up like this. So the water molecules are going to surround, the negative end of the water molecule is going to surround the positive end, or the positive ion there. Okay, and then over here with the chlorine, you're going to have this interaction where the positive end of water, which is the hydrogen, is going to surround your negative chlorine. Okay, and so this is dissociation, so it causes the ions to separate from each other. Okay, now your process of solvation is going to be, we're going to use this with your covalent compounds, so we're going to solvate these. And so basically what this means is if I've got something like, let's look here at methanol. Okay, so here's your structure of methanol. And what's going to actually end up happening here is that your water molecules are going to come in and they're going to kind of hydrogen bond here at this point, and so you'll have another water molecule that'll come in here and have an interaction there. And so basically these water molecules are going to end up surrounding, and so you have some other waters in here, but they aren't really bound, or they aren't really interacting with this part of your molecule. But this is how it's going to pull these molecules apart. So let's say I have a bunch of these stacked together. The water molecules actually come in between these and they pull them apart so that they surround one individual one. Okay, so depending on how much water you have, that's going to determine if your solution becomes saturated, supersaturated, unsaturated. But we'll talk about that in another video. So in this one we said we were talking about electrolyte solutions. So in order for something to conduct electricity, there must be positive ions in the solution. So your ionic compounds are going to be the only things that conduct electricity in a solution. Okay, so an electrolyte solution, okay, this will conduct electricity. It must have cations. So we dissolve salts, and by salts we mean any ionic compound. In water. You can also have your acids and bases. And we'll talk a little bit more about the acids and bases, why those work. But remember again, and you have to think about your solubility rules too, because if something is insoluble, so we go back to this, right? So any of these, if you have something like silver chloride, you put silver chloride into a solution, it's going to stay as a solid because it's insoluble in water, so it won't break up. So these are all things that are going to break up into ions. So remember, it's got to break up into a plus or in your minus charges here. Okay. So this is an electrolyte solution. Something like what we talked about over here, like this here, your methanol. This is a covalent compound, okay? Covalent, sorry. All covalent compounds do not, okay, these do not conduct electricity. So sugar will not conduct electricity. If you guys think back to the lab that we did, okay, we talked about, you guys use your conductivity testers, and you tested the conductivity of all of your ionic solutions. All of them conduct electricity. All of your nonpolar or covalent compounds, they do not conduct electricity because they do not break up into pluses and minuses. You have a partial positive and a partial negative, but that's not the same thing as having a full positive and full negative. So your covalent compounds, they do not conduct electricity. So a couple of examples that you guys will know of a solution that will conduct electricity. So it's anything that has acids, bases, something like an orange, like orange juice. Orange juice will conduct electricity because it's acidic. Gatorade, it'll conduct electricity. Lemons, limes, all of that stuff. If you look at the back of Gatorade, it's going to tell you it has potassium, it has magnesium, I'm trying to think what else, but it has these ions, okay? And these ions allow the electrons to flow in the solution. Okay. That should be all you guys need to know as far as your electrolyte solutions. So check the next video, which will end up being types of solutions.